Okay, welcome back. This video is going to be about describing direction and acceleration and what that means. Okay. Direction can become confusing because not only can you use a plus sign for moving to the right, but you can also think of a plus sign as being used for speeding up. If your acceleration is positive, that tends to make you think that it's going faster. And then a negative sign could be considered left, but it can also be thought of as slowing down. Unfortunately, you can do both of these things, left or right, which confuses the issue even further. How would you do speeding up left then? Speeding up, positive, but left, negative, makes the whole thing complicated. So the way you have to envision acceleration is with a little string that's tied to the object and pulling it in a certain direction. And the key to remember is that you do not have to be moving in the same direction that you are accelerating. I should probably write that so that people will remember it. The direction of acceleration does not, and I'll underline the not, have to be the same as the direction that you are moving in, or I guess the direction of your velocity. But I'll put the direction, you are moving in. Or not necessarily you, but any object, right? In other words, it doesn't have to be the same as the velocity direction. It's possible to be moving to the left and accelerating to the right. And this is what we're going to illustrate. So I'm going to try to draw the pictures here as best I can. Let's imagine that you were here. Okay? Now, to show you going slowly, I'm going to draw you walking. But to show you going fast, I'm going to show you running. See the difference? Slow and fast. So in other words, your speed would be increasing. Well, the way this could happen is if you tied a string around your waist and pulled the string to the right, it would cause you to go faster and faster to the right. Okay? But if you envision somebody starting here and walking slowly, sorry, I got that backwards. Walking fast, running fast. Let's make them running fast here in the other direction. So running fast, and then over here ending up going slower. Well, the string would still have to be pulling you in the same direction. So the positive acceleration would cause this person, as they moved this way, to get slower and slower and slower. So positive acceleration can cause speeding up to the right, but it can also cause slowing down to the left. And if we drew another picture in just the opposite way, we don't have to draw the pictures, but I think you can see that if we pull the strings the other way, so positive acceleration here is causing speeding up right. But it's also causing slowing down left. So it causes what appears to be two different things, but is really the same acceleration rate. Now, if I did the arrows the other way, if I drew two green arrows showing a string pulling a person this way, you could reverse it, and you could make the connection that the negative acceleration, what it would cause would be speeding up left, and it would also cause slowing down to the right. Which in physics is exactly the same thing. even though in reality it looks like two different things, it's the same pull of the string. It's the same effect, right? So what we'll do is we'll make a little chart to summarize. We'll put the words speeding up here. We'll put the word slowing down here. We'll put a little right over here. And we'll put a left down here. And we'll turn it into a nice chart. People like nice charts. There. Now, if you recall, we said that speeding up makes you think of a positive acceleration, and slowing down makes you think of a negative. Also, right makes you think of a positive, and left makes you think negative. Now let's crisscross them. In fact, if I use a different color here, that could even make it a little bit clearer. So I'll use blue for these guys. So this is a plus and a minus. If I match up the first two, I get a plus from the speeding up matched up with a plus from the going right. Well, two pluses make one big giant plus. So a positive acceleration for speeding up to the right. If I match over here on the second one, I get a negative for the slowing down, but I get a plus for the right, and a plus and a minus in math go together to make a negative. So negative acceleration is slowing down to the right, or deceleration. And then if we go down to the bottom, we get a plus and a minus for speeding up and left, which of course would produce overall a minus. And then for slowing down, we get a minus, and then we get a minus, and two minuses make a plus. So this reminds us what positive acceleration can mean and what negative acceleration can mean. Okay? And while we're at it, we'll just mention the unit once again. We've already mentioned this, but just so we have it on video somewhere, the unit is meters per second squared, which is also written as meters per second per second. It could be written that way, or said that way, meters per second per second. And what it means is that the speed is changing by a certain number of meters per second every second. Right? So let's give you a brief example of that. If you were going 2 meters per second, and then 1 second later you were going 5 meters per second, then you have increased your speed by 3 meters per second in 1 second, or 3 meters per second per second. Get it? And that's what your acceleration rate would be. Or we would just simply write 3 meters per second squared. And so that's how we deal with the unit for acceleration too, just as a reminder. And that's basically the end of that.